There was recently on LinkedIn, in the senior DBA group, an interesting discussion that started in May 2016. And after a few days, it had numerous likes and a lot of comments, but it did get a bit confusing. It was talking about these sort of things, online redo logs, undo segments, and people were confusing redo with undo. It was also talking about checkpoints and transaction commits. Again, there was confusion about that. So my response to this is just a short presentation on undo, redo, checkpoints and commits. Itself is undo tablespace. Totally different in terms of usage and structure when compared to redo log files. Opposite, because the undo is an undo tablespace. So that's basically used for users and transactions. The redo log isn't a tablespace, it's files. And that gives you a bit of a clue. That's internal to Oracle, realistically, and that's used for recovery. Also, database checkpoints are nothing to do with committing transactions. The one thing I would point out just at this stage, though, there is a link between checkpoints and redo log files. So just looking at the undo tablespace, it simply contains before images of data blocks that have been read into the SGA and have been amended. It's used for reconsistency. Oracle guarantees that you get a consistent view of the database from any query. It is also used for transaction rollback, and it's at process level. So if I lose my connection to the database, the PMON background process monitor would detect I've lost my connection, and it would tidy up my transaction. And it reads the before images to do that. More recently, it's used for these flashback functionalities: query, version query, transaction and table. And the reason we put those in now is they also use before images to change data blocks. And what you find, if you're using these flashback or would like to use them, you've got to keep the information in the undo tablespace for a lot longer. For reconsistency transaction rollback, you don't need to keep them for that long. Depends on your maximum query length. But if you want flashback query, you're looking into keeping things in the undo tablespace for a term of hours rather than minutes. So the objectives that we have as DBAs is reduce the RF1555 errors, snapshot too old. And if you've chosen to plan for using flashback, that's the objective. We've got to plan for that as well. So the decisions you've got to make are the size of the undo tablespace, the undo retention parameter value. The other thing we need to decide if we are having flashback is whether on the undo tablespace, this isn't a parameter, it's an alter tablespace, whether we want to guarantee that retention or not. The good tool you've got for all this is VDollar_undo_stat. So have a good look at that data dictionary view. Redo log files now, they are mandatory. And Oracle has them for database integrity. So if you commit a transaction, Oracle will guarantee it's been written to disk. It's not been written to disk from the SGA back to the data files, it's been written to the online redo log with a fast commit marker. So it's permanent, unless we lose the online redo logs, of course. It's good performance because we only write the online redo logs, we only write change vectors. That's why it's so good for good performance, and it guarantees the integrity. It is used in instance recovery, where if your database has crashed, uncommitted changes potentially which have been written back to the data files, they need to be rolled back. You'll also have committed changes either in the online redo log with a fast commit marker, but they have not been updated on the database. So when we restart the instance, SMON, System Monitor, will perform the recovery using the redo information. Just the terminology, each online redo log file is a member of a group. The minimum configuration which Oracle will run with is just really 2 files. That's actually 2 groups, each with 1 member. Suggested minimum configuration is 3 groups at least, each with 2 members. That's called multiplexing the online redo log. So 6 files in total, 3 groups, 2 members each. On the data dictionary, you've got quite a lot of data dictionary views to do with log files. I'm showing you here, I've got the 3 groups, which I've suggested, and in each group there are 2 members. So that's being multiplexed by that one. It's writing to both of them at the same time. Don't forget there's a difference between mirroring and multiplexing. Starts on group 1, goes to group 2, group 3. Now Oracle's not really interested in those groups. What it's interested in is the sequence number. The other important thing there is the status of this current log file. It's a column called status, and current means it's the one that's being used at the moment. Log writer is writing to it. Active means it's switched over from that one, but that one is still required for instance recovery. When it's inactive, means all the contents have been dealt with, so it's no longer needed for instance recovery. So this is just showing you how we use the redo log file. Simplified it now because it doesn't matter how many members we've got. But in this case, I've used group 1 and I've switched to group 2. We're now on group 2, So if we look at the current situation, group 3 is currently being written to. So what we've got is what we define as the redo log tail. It's where logwriter is currently up to with writing to the redo. The other important one we've got, though, is the checkpoint position. Checkpoint position, anything to the left of the checkpoint position, say for instance it's there, the checkpoint position, anything to the left of that has been dealt with. So instance recovery starts from the checkpoint position. Now as soon as we move on a little bit, we're still writing to the online redo logs. It doesn't wait, but we'll also be checkpointing at a log switch. So when that checkpoint is completed, that one will be inactive, no longer required for instance recovery. So the checkpoint position and the redo log tail are very important. The difference between, or the distance between the checkpoint position and the redo log tail dictates how long recovery would take if the instance crashes. So if you imagine I've got that scenario there where the checkpoint position is quite a long way from the redo log tail, recovery would take a certain amount of time. If we make Oracle checkpoint more frequently, checkpoint position might be there. You see, therefore, if I do recovery, it's a much shorter period of time because it's much less to roll forward and roll back. That's for $log data dictionary view, $log file. So we normally do a join on the group hash, the group number. If we look at instance recovery though now, it's where the database is inconsistent. The system's crashed. Somebody's done a shutdown abort. What Oracle has done then is the redo marker in the control files is still open. So when we restart the Oracle instance, we've got the recovery, which is now performed by SMON, System Monitor. And it does it after the database has been mounted. And between the mounting and finally saying opened, SMON is performing instance recovery if required. So it brings that checkpoint position, is where the checkpoint is up to the redo log tail, which is where we're currently writing to. It rolls forward any committed changes, and it rolls back any uncommitted changes. And the important point is this one. It only uses redo entries. It doesn't refer to the undo table space at all. So if we now talk about checkpoints, checkpoints are a balance between recoverability times and ongoing performance. So the checkpoint is synchronizing memory and disk. We do get checkpoint, we do a shutdown normal, immediate or transactional. You can have it when you do an alter system checkpoint. There's not a lot of reason for doing an alter system checkpoint. It also happens on an online redo log file switch. We have what we call a partial database checkpoint. That's when we take the table space offline. Therefore, that table space's data files will be checkpointed. So it's a partial one. It's not all the database, it's just that. If we put a table space from read-write mode, which is defaulting to read-only, we've got to checkpoint it. So to use incremental database checkpoint, it's one of these three parameters. So I don't really like either of those two. So what we tend to use this time is fast start MTTR target, which is in seconds. That is the mean time to recover. So it's saying in seconds how long you would like the recovery to take. Now obviously you don't want the recovery to take too long, but the more aggressive we are with fast start MTTR target, i.e. the lower the value, the more aggressively we're checkpointing. Therefore it does affect performance. The less aggressive we are, set MTTR target to a very high value, then we're not aggressively checkpointing, so performance is better at the moment, but if system crashes, it'll take longer to recover. It's on $systat, the name and the value, where the name is like, and it is case sensitive and it's lowercase, and that will tell you the number of background checkpoints started and completed. The problem we've got is if we take a checkpoint for whatever reason, and then, say for instance we're using fast start MTTR target, and we start a checkpoint because that's been met, if very soon afterwards we switch log file, that instigates another checkpoint. So Oracle will basically abort the first checkpoint and start another one. So that's a total waste of time. So if background checkpoint started is a lot higher than background checkpoints completed from this $systat, we know that the two mechanisms are producing checkpoints that are overlapping with each other, and that's a waste of resource. So the size of redo log files, as I said before, you've got to look at the smallest redo log files. Here we've got smallish ones. The checkpoint position, yeah, that's where the checkpoint is up to. The redo log tail is where we're currently writing to. And the thing is, if the system crashes now, SMON would do the recovery from the checkpoint position to redo log tail to make everything up to date. So it's that size. If you just make your redo log files larger, then the recovery extends. Because there's the checkpoint position again, there's the redo log tail. So it allows the checkpoint position to lag behind the redo log tail, so it means longer recovery times. but better performance day to day. So all I'm saying now is just be careful. I'm not telling you how big your redo log files should be, but I'm saying it does have an effect. You increase the size of them, it increases recovery times, but potentially gives you an improvement in performance. And obviously it's the other way around. If you decrease the size of redo log files, the recovery is going to be faster, but performance may be affected. Again, when I'm just looking here, it might look like the same slide there, but it's not. If you look at this, the effective decrease of MTTR target. Again, your checkpoint position was there, now there, so that's the recovery time. If we decrease the MTTR target, you see the recovery is increased, because it's allowing the checkpoint position to lag behind to give us better performance, but recovery will be longer. Now if I just go back to the previous slide, effective increase redo log files, has the same effect as decreasing fast start MTTR target. So if you want more checkpointing, we just change fast start MTTR target. So what are DBA's objectives? Well, from the redo log file point of view, we've got to protect against a single point of failure. When a transaction commits, the guarantee is it's written a fast commit marker to the online redo logs, and that enables Oracle to recover it, roll it forward. It's got the information in the redo. If we've only got one member in each group, and if we lose the current or an active redo log file, let's just talk about the current one from now, if we physically lose that file, it gets corrupted. We've lost the only one marker that was in disk to say that particular transaction was committed. So it can't roll it forward anymore. So if we only have one member in each group and we get one damaged that's currently being used, we're into a restore and a roll forward. We're into a point in time recovery before we start on this redo log file. So simply by multiplexing, we have at least two members in each group. That means Oracle is writing to both at the same time. And if we lose one of them, Oracle will actually continue processing. As long as Oracle can write to at least one member in each group, it can process as normal. Taking checkpoints, we've got to balance performance against instant recovery times. Aggressive checkpoint is good recovery times. Non-aggressive checkpoint is better performance. So it's a balance between the two. What I think about that is we should really have good performance against acceptable recovery times. So you have to decide how you want to drive the checkpoints. The redo log file size, as we've seen, can affect the checkpointing. Fast start MTTR target can affect the checkpointing. So decide which one of those you want to control your checkpoint frequency by. Very good Datadix review here to help us out as well is $V instance recovery. That will tell you currently the estimated MTTR against your target. So whatever we set these values to control the checkpoints, which controls the recovery times, we must make sure that we're also always matching the service level agreement, the SLA. In our production database, if you don't have an SLA, I would suggest you get one. This is talking about commits, which is nothing to do with checkpointing. We're moving on again now. We commit a transaction, or we roll back the transaction. The transaction starts as soon as we do any updates to the database. So it may be an update statement, may be a delete statement. So your transaction is now started. So it's a logical unit of work that contains one or more SQL statements. So it starts with the first DML, data manipulation language, into update delete, and this particular transaction ends when we explicitly commit. That means we use the SQL verb commit. Be very careful though, because we have implicit commitments as well. So you're actually doing some work, and you don't want to commit your work yet because you're transferring money from one account to another. If you just do something which not meant to be related to it, but you do a piece of DDL like drop a table that you don't want anymore, DDL ends the transaction because it does an implicit commit, so it will have committed all your work in progress. Issuing a rollback, or PMON, deciding you've lost your network connection, for instance, and it will roll back your transaction. So just compare checkpoint to commit. They're nothing to do with each other. Checkpoint synchronizes memory and disk, so it can reduce recovery time, but it is detrimental performance if it's too frequent, if we're too aggressively checkpointing. Commit, which is nothing to do with it, that's to do with transaction, guarantees the permanency of a single transaction, and it does that when you commit a transaction by writing what we call a fast commit marker to the online redo log. And it's got things like the SCN, system change number, it's got the transaction ID, and it's also got a time it was actually committed. So you see from there, that's at system level, this is per transaction level, and they are nothing to do with each other. You can commit as many times as you want, doesn't mean you've had a checkpoint. You can checkpoint as many times as you want, you've not committed anything. So they're totally separate. nothing to do with each other.